All right, I'd like to talk to you about the number 142,857. So I'm going to type that into the calculator, 142,857. I'm going to multiply this number by 2, and I'm going to get 285,714. Then I'm going to multiply this number by 3. I'll change that to a 3. We got 428,571. Now I'm going to multiply this number by 4. And we get 428. Then I'm going to multiply this number by 5. 714,285. Then I'm going to multiply this number by 6. 857,142. Then I'm going to multiply this number by not 9. I multiply it by 7. And I gave it away. It turns all 100% into 9s. So what's going on with this number right here? Well, this number is called a cyclic number because there's a cycle that's happening here. Do you see the cycle? 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. And that was just doubling this number. Then I tripled the original number, 1, 4, 2, 8, 5, 7. Then I quadrupled the number, 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. 1, 4, 2, 8, 5, 7. And then it turned all the 9s. And I'll explain why that happened in a second. Basically, this number comes from a division problem. So let's do the division problem where this comes from. 1 divided by 7. Well, you can't divide 1 by 7. It's a fraction, it's 1/7, and it's like basically you're admitting to the whole world that you can't do this problem. You have one pizza, you're dividing amongst 7 people, so everybody gets 1/7. And then it's like, oh yeah, there's decimals, so I can actually divide this. So here we go. We're going to do 7 divided 1.00000. I think that's enough. Maybe it's too many. I don't know. We'll find out in a second. No. So we put a 0 here. Bring the decimal point up. 10, yes, 1 time. 7. We subtract. We get 3. We bring down another 0. It goes in there 4 times. 4 times that is 28. We subtract. We get 2. We bring down another 0. We multiply, or not multiply, we figure out what we need to multiply, 2. And then we get 14, we subtract, we get 6, we bring down another 0, and 8 times 7 is 56, we subtract, we get 4, so now we bring down another 0, that's 40, 5 times, 6 times is too much, so it's 5 times, be 35, subtract, we get 5, 0, oh, close, it's real close, 7 times, it almost went in even. 49, we subtract, we get 1, we bring down another 0, and then we're back to 10, which is where we started out with. Basically that's 10, and then the next one will be, so this is a repeating decimal. So that's where this number comes from. 142,857 is basically the repeating digits for 1/7, and then when we doubled it, that's the repeating digits for 2 7s, 3 7s, 4 7s, 5 7s, 6 7s, and that would be 7 7ths, which would be the same thing as 0.9 repeating, right? Because it's 1. 0.9 repeating is 1. So this is the digits for 1/7, 2 7ths, 3 7ths, 4 7ths, 5 7ths, 6 7ths, and this would be the repeating digits for 7 7ths, which is the same thing as 1, which is the same thing as 0.9 repeating. So that's where the cyclic number comes from, 142,857. It comes from the repeating digits of 1/7. Now, This is something that, you know, it's known about, no big deal or whatever, but it's kind of a cool thing. This is something I've never seen before, and I was like, what if we took these 6 numbers and evenly distributed them around a circle? Well, they would all be, a number would be every 60 degrees, right? So I did that. I'm going to go up a little bit higher so we can make sure that we see all this. So I adjusted. I'm still in focus. I'm good. We are going to start off here. This 1, 4, 2, 8, 5, 7. So this would be my starting point, and this would be the place where you'd start with the digits for 1/7, and you go around, and that would be the repeating digits. And it just, once you get to 7, you go back to 1. You just keep going around the circle and around the circle and around the circle. So where is your next starting point? Well, that would be down here. 2 7s is 2, 8, 5 repeating. So you start at this point. So 2 7s would start down here. Okay? And you go around the circle, around the circle, around the circle, around the circle. Then 3 7s. Where's 3 7s going to start? Well, 3 7s is going to start with the 4. So it's going to be right here. So this 3 7s would start here. And then 4 7s, where's that going to start? 4 7s starts with a 5. So that's going to start over here. And then 5 7s. 5 7s starts with the 7. So that's going to start here. So 5 7s starts here. So 5 7s is 7, 1, 4, 2, 8, 5, 7, 1, 4. It just keeps going around the circle that way. And then the next one, 6 7s, would be the only place left to be down here. 6 7s starts right here, 8, 5, 7, etc., etc. So now we're going to connect these starting points. And the only way to connect anything is with the McRuler here, McMetrics. So this is out of a Happy Meal or something from the 70s. And it's pretty cool. It's like, hey kids, metrics are cool. Anyway, so we're going to connect these starting points, and look what happens. So we're going to connect from here to there. So there's my next starting point, and then I'll go back up to here. And then over to where the 4 7 starts. Again, these are just evenly spaced out around the circle every 60 degrees. And then 5 7 starts up here. And then 6 7 starts down here. And then, just to make it fill out the picture, I'm going to go back to the beginning. And look at that awesome pattern. So we'd start, we'd move down here, and then go around for that repeating decimal. Then you go here, you go around for that repeating decimal. Then you go over here, you go around for that repeating decimal. And then over here, around for that one, and then down here, around for that one, and then you could go back and talk about 1/7 again. So that's really kind of cool. But there's other repeating decimals that repeat along numbers of spaces. The next one that's really cool is 17ths. So I'm going to find the 17ths one here. Let's see, I'm looking through my papers. 17ths. So here's the picture for 17ths. It is a whole bunch of numbers repeating. So let's see, if we start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which is really awesome because 16 times 20, no, not 16. I can't do math in my head, it's after school. 360 divided by 16 is 22.5 degrees. So every 22.5 degrees, I marked off where the number should be to space them out evenly. For some reason I was thinking it's 20 degrees, but that's only 320. It's 360, so it's 22.5 degrees. So we start here with 0, and so 1/17 is 0.058823524116767. Wow, that's rough. And then we just go to the next spot. Okay, so the next starting point is down here. Okay, then the next one's here, and the next starting point's over here, and then it's and then it's here, and then it's there, and then it's over. It just keeps going around, and look at the pattern it makes. So it's like here, and then it's there. So that's pretty neat, and that's 16 digits that repeat. 19ths have a ton of digits that repeat. Is that even more? Let's count them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18, yeah, that would be every 20 degrees, because 360 divided by 18 is 20. So every 20 degrees I put a number. So here's 1/19th is here. So 1/19th is 0.052631578946736842 and that's the repeating digits from here. But then where's the next starting point? The next starting point is right here, and then it goes here, and then it goes up to here, and then it goes over to here, and then it goes down. So, but look at the pattern that's happening here, and it's more complicated, but you can kind of see it and how it's like twisted around, and it matches all up. Now, 13ths are weird. This was my exploration of 13ths. Is they have different repeating. They only repeat 6 digits. Well, there's how I figured out the 19ths. But so it's 076923, and then it's right here 076923. It's every other one is the same. No, these are the same. Wow, this is like really tripping me up, because the boxes are all the same repeatings and the stars are all the same repeatings, but there's like 2 sets of repeating numbers. So what happened? How do you deal with that? Well, I made this picture right here for 13ths. So notice that some of the numbers are boxed in. Whoops, there it's on the screen. Some of the numbers are boxed in, and some of them are just regular numbers. So it would be 07, because it's not boxed, so it's 076923 are the digits repeating for that one. Then the next digit that's repeating starts with 2 13ths, which is here. So those repeat 1, 5, 3, 8, 4, 6. So so I just kind of alternated them in between each other. So I have the ones that are the repeat off the first one, and then the ones that repeat off the second one, and I went every other one because there's 6 of them. And then so there'd be 12 total, and I just alternated. But look, it still made a pattern. You can see how this matches with this matches with over here, so it still made a cool pattern even I did that. Now, the next thing I tried to do is I was like, well, what if I put one set of numbers on one circle and one set of numbers on another circle, and then try and connect it to show a pattern? And that was kind of an epic failure. So not everything is nice. So I put one set of repeating numbers on one circle, one set of repeating numbers on another circle, and it just kind of turned into a big mess. Here, let me turn it sideways so you can see all at once. I don't know, maybe if you studied it forever you'd see some kind of pattern. It's just not real nice. Something weird is happening here. All right, and it's slightly out of focus on one side too. Let me see if I can get it into focus. There we go. Yeah, it's a little bit better. So this to me was kind of an epic fail. I tried to put one set of numbers on one circle, one set of numbers, and I tried to connect them all together, but it didn't really work out so well. It looks better when I did the every other skip thing, because you can actually see like a real pattern here. All right, so the moral of the story is we have these cyclic numbers. And where do the cyclic numbers come from? They come from the cycling through of the repeating decimal. Now I can't find my original page to summarize this. Where'd it go? Here we go. So here's my original page. Refocus in here. Boom. So there's the original number we started with. And where did that number come from? It came from the decimal equivalent to 1/7 as a repeating decimal, and then you just multiply it, which creates 2 7s, 3 7s, etc. But putting it on the circle and seeing this pattern was kind of, the first time I did it, I was like, I didn't know what I would expect. But it's so simple, yet it's very, very rewarding.